Hi guys! In this video, this is the second part of differentiation. So we will discuss about the differentiation of ln x and e to the power of x, and then we continue to the rules of differentiation. If you haven't checked the first part of this video, you may go to check it. You can check from the link in the description. Okay, let's start the differentiation of ln x and e to the power of x. If we have a function y equals to ln x, so the derivative of ln x dy dx is equals to 1 over x. How do we prove this derivative? So to prove this, you need an understanding of a natural number. So we have an identity if we have limit for n approach to infinite from 1 plus 1 over n to the power of n. This will be equals to a natural number called e. So this e is coming from the expansion of the term 1 plus 1 over n when n goes to infinite. So if we expand this expression, and it will lead us to a number 2.71 something, and we call it as a natural number. Now we need this identity to prove the derivative of ln. So again, if we have y equals to ln x, so fx equals to ln x, so fx plus h will be equals to ln x plus h. And using the first principal method, dy dx is equals to limit h approach to 0 of fx plus h minus fx to the power over h. So we can continue limit h approach to 0. So this is ln x plus h minus ln x over h. And then I can continue. I put 1 over h. And then I have ln x plus h minus ln x. So if you remember the rules of logarithm, when we have ln a minus ln b, we will have ln a over b. So we can combine ln x plus h minus ln x become ln x plus h over x. Okay, so now limit h approach to 0, 1 over h. I can continue to simplify this as x over x is equals to 1 plus h over x. And then now I can put 1 over h out from the limit, and I put the limit inside the ln. I have ln limit h approach to 0 of 1 plus h over x. Now, we have to change this form into this form. We see that it applies for limit n approach to infinite value of 1 plus 1 over n to the power of n. So to make it equals to e, we have to make n as the infinite value. This is 1 over n, and the power is n. So how do we change this form into that form? So we have 1 already. So we need 1 over n. So we have to change 1 over h ln limit h approach to 0 this is 1 plus 1 over x over h. Okay, we have similar form, but it's still h approach to 0 instead of h approach to infinite. So we have to change it. Now, if you see from here, when h is approach to 0, then the x over h will approach to infinite. So if I say n as the x over h, so I can rewrite this as limit 1 plus 1 over n goes to infinite. I can change that. So when h equals to approach to 0, so x over h is approach to infinite. So I can say n as the x over h will be as well as goes to infinite. So n will goes to infinite when h equals approach to 0. And then this is ln, this is 1 over h. Now, again, rules of the logarithm. If you have a ln b, you can change into ln b to the power of a. So I can put 1 over h as the power. So it's ln limit and approach to infinite 1 plus 1 over n to the power of 1 over h. Now, this is not the same. This is h here. This is n. To make it the same as it is, we have to change it into n. So we change it. So n is x over h. So if I can multiply this by x over x, so I will have ln limit n approach to infinite 1 plus 1 over n to the power of x over h times 1 over x. I switch the position of x in the numerator, and it leads us to n goes to infinite 1 plus 1 over n to the power of x over h will be n. Yeah, x over h will be n 1 over x. Now, this term will be equals to e. Yeah, for this term, this part. So it's to the power of 1 over x ln. So now we have, again, using the rule, we can put the power in front. So it's 1 over x ln e. Ln e is equals to 1. So it's 1 over x. So it's proven, shown, that when the fx is ln x, the derivative dy dx is equals to 1 over x. So this is the proof. But we can just use this rule later on. Okay. Now, how about the derivative of e to the power of x? If we have y equals to e to the power of x, so the derivative dy dx is equals to e to the power of x as well. So it doesn't change. Okay, how do we prove this? Now, As we know, the derivative of ln x is equals to 1 over x. So we can derive e by use that rule. So y equals to e to the power of x. And I need the help of ln. So on the both side, I will do ln e equals to ln y. Yeah. So ln y equals to ln e to the power of x. And then now, so ln y equals to ln e to the power of x. And now on both sides, I will derive with the respect of variable y. So the derivative notation here, the dy over dx is a notation of differentiation. So that means we differentiate a function of y. So we can rewrite dy dx as this. Dy dx equals to d dx from y, because we will derive the variable x. Now, in here, we have variable y. So I want to derive the function with respect to variable y. So it becomes d over dy. So I derive both sides with respect to variable y. And ln y derived with respect to variable y is equals to 1 over y. Yeah, if you remember, if ln x derived with respect to variable x equals to 1 over x, so when we derive ln y with respect to variable y, it will be 1 over y. And this equals to the derivative of, we can change this form into d dy of x ln e. Yeah, we can put the x outside, yeah, from the power. And ln e equals to 1. So it's dx over dy. So now if I have dy over dx, I can just switch the position. It's equals to y, and y equals to dx. So that means dy over dx will be equals to e to the power of x. So shown. So if you have e to the power of x, you derive it, it will be the same as e to the power of x. Okay, let's see the example. Find the dy dx of the following function. Number 1, y equals to 3 ln x. So dy dx will be equals to 3 times the derivative of ln x is 1 over x. So equals to 3 over x. Number 2, y equals to 3ex. So the dy dx will be equals to 3 times the derivative of ex is equals to ex. Yeah. Okay. Now we continue to the rules of differentiation. We have some rules of differentiation. The first one is the chain rule. So the chain rule is used to simplify the complex expression to be derived in the basic form of differentiation. So we have to remember the rules from the beginning. If we have ax to the power of n, the first derivative will be equals to n times x to the power of n minus 1. Yeah, the power multiplied to the front, and then the power is minus by 1. And if we have ln x, the derivative is 1 over x. If we have e to the power of x, the first derivative is e to the power of x. So the chain rule is a rule to convert the complex expression back into this basic formula. So let's see. We have to express the function in the variable of u, yeah, to simplify the expression. And then it will follow this rule. So we will see how this rule works. So for example, y equals to 2x plus 6 to the power of 4. In this case, this form is familiar to the first expression. It's ax to the power of n. Yeah, I erase this. So this is the original function. So ax to the power of n. And this form is similar. So we can make this expression into ax to the power of n by making y equals to u to the power of 4. Su equals to 2x plus 6. See? This is similar with ax to the power of n. So what is the derivative? So if we derive dy over du, yeah, since now our variable is u, so the first derivative is not dy dx, but dy over du, because we have the variable u. So it will follow the rule, the basic rule. So the power move from to 4 times u to the power of 3. Yeah, as the basic formula goes to n times a x to the power of n minus 1. It will follow this basic formula. Yeah. Okay, so we have 4u to the power of 3. But again, we need to find the dy dx instead of dy du. So how do we find the dy dx? We have dy over du. So we can manipulate dy dx can be found using the dy du times the du over dx. Yeah, see, if we cancel this, it will be equals to dy over dx. So the left hand side and the right hand side will be the same. So this is called as the chain rule. So that means we have dy du as 4u cubed from this one. But we don't have du dx, so we have to find the du dx from here. If we have u equals to 2x plus 6, so du dx will be equals to 2. So we can multiply it by 2, so equals to 8u cubed. And we replace the u back, so 8 to x plus 6 to the power of 3. Yeah, this is the answer. Yeah, so this is the chain rule that you have to remember. So the dy over dx can be found by dy over du times du over dx. The first part is the derivative of function u. So I can rewrite this as the f prime u as it is. And du times dx is the derivative of u, so u prime. So this is the notation. This is the rule for the chain rule. So we derive the function u normally as we derive the basic function. And then we multiply it with the derivative of the inner function. Yeah, the function that we assume as u. Okay, so we can see the next example. Now, how about learn for x? So I can change this into y equals to learn u as u equals to 4x. So learn u. If you remember, if we have learn x, the derivative is 1 over x. So if we have learn u, the dy du will be equals to 1 over u. And the du over dx is equals to 4, yeah? Now the dy over dx will be equals to dy over du times du over dx. So this equals to 1 over u times 4 equals to 4 over u, and we replace it for x equals to 1 over x. Number 3. So the same, we can assume this as u. So y equals to ln u as u equals to 3x plus 4. So again, we derive the function normally as 1 over u, and the u is derived du over dx equals to 3. So the dy over dx will be dy over du times du over dx equals to 1 over u times 3 equals to 3 over 3x plus 1. Yep. And for number 4, so we can assume this as u. So y equals to eu. Now remember, ex derived is ex. So that means eu is derived with respect to variable u as eu. And the u is x squared minus 3x. So the u dx equals to 2x minus 3. So dy dx is the dy du here, e to the power of u times du dx. So 2x minus 3. So it's 2x minus 3 e to the power of x squared minus 3x. Yeah. So if you see, all the examples are following the rules of u for the dy dx equals to f prime u, you derive the function, times with the derivative of u. Yeah, again, if you see number 2, y equals to ln 4x. So the dy dx is, we just do the derivatives ln normally. So it's 1 over 4x, 1 over u, yeah? Because ln 4x is ln u. The derivative of ln u is 1 over u. Yeah, this is u, so it's 1 over u. Times the derivative of u, which is the derivative of 4x is 4, equals to 1 over x. Yeah, we can use this formula directly. Number 3, y equals to ln 3x plus 4. So this is u. So dy dx is, derivative of ln u is 1 over u times derivative of u. Derivative of 3x plus 4 is 3. So 3 over 3x plus 4. And the last one, y equals to e x squared minus 3x. So we can assume this as u. So dy dx is eu. Yeah, just copy, times derivative of u, derivative of 3x cubed, x squared minus 3x, so x minus 3. So you will have the same answer directly without using this long method. Yeah, you can do it directly using the chain rule. Yeah, just you derive the function normally and then multiply with the derivative of the inner function. This also in some exercise you can try for your own practice. Now we move on to the second rule. It's called as a product rule. The product rule is used when we have two or more functions in multiplication. So if we have y equals to function u times function v, so the derivative of the function y is u prime v plus u v prime. So we derive the function alternately. Yeah, we derive the u first multiplied by the v. So this is the du dx. And then we plus with u times the v prime. This is the dv dx. So we derive it alternately. And then we simplify. For example, like this. So we can, in this form, we can expand. Yeah, we can expand it. Let's try to expand it first. Let's try to expand it first. Y equals to 12x squared minus 3x plus 32. So minus plus 29x minus 8. So y we derive, yeah, dy dx equals to, this become 12 times 2, 24x plus 29. Now, we use the product rule. So if we use the product rule, 3x plus 8 times 4x minus 1. So the first one will be u, the second one will be v. So u is 3x plus 8. So u prime is, we derive this, 3. V is 4x minus 1, v prime is 4. So the function y prime is u prime v plus u v prime. So u prime is 3, v is 4x minus 1, plus u. So u is 3x plus 8 times v prime is 4. And then we simplify 12x minus 3 plus 12x plus 32 equals to 24x plus 29. So the same result. Yeah, that's number one. Maybe it's easier to expand instead of using the product rule. But if you have question number 2, it's impossible to expand this. That's why we need the product rule. So this is u, this is v. So u is x plus 4 squared. And the u prime is, we need to use the chain rule here. So we use the chain rule. So this is u squared. Treat as u squared. So it's 2u to the power of 1 times derivative of x plus 4. Yeah, times u prime. So times 1. So equals to 2x plus 4. V is 4 minus 2x to the power of half. So this is again, this is also u to the power of half. So we derive it as, using the chain rule, half u minus 1. Jadi minus half, yeah? It becomes minus half. And then times the derivative of the u, the inner function. It's negative 2. So equals to negative 4 minus 2x minus half. Yeah, this is minus 1. Okay, So we put the formula u prime v plus uv prime. So u prime is 2x plus 4 times v, 4 minus 2x, half, plus uv prime. U is x plus 4 square. V prime is negative 4 minus 2x minus half. Now we can simplify by factorizing. We can see that we have the same term, x plus 4 and x plus 4 square. So we can take out the x plus 4 square, x plus 4. And then we have also the other 4 minus 2x half and 4 minus 2x negative half. So we always take the smallest power. So it's 4 minus 2x to the power of negative half. We take the smallest. And this remaining, from the first term, it remains 2 and 4 minus 2x to the power of 1. Yeah, because we already have this, so we divide, yeah. 2x plus 4 divided by x plus 4 is 2. And then 4 minus 2x half divided by 4 minus 2x to the power of negative half is equals to 4 minus 2x to the power of 1. So I rewrite here. It's 4 minus 2x to the power of 1. Okay, next. The second term, it's plus and minus become minus. So we have x plus 4 square here and x plus 4 at the front. So it will be x plus 4 remaining to the power of 1. Yeah. And then for the 4 minus 2x negative half, we have 4 minus 2x negative half. So that's only 1. Okay, now simplify. So it's x plus 4, 4 minus 2x negative half. And then we have, what is this? 8 minus 4x minus x minus 4 equals to x plus 4, 4 minus 2x minus half. And then we have 4 minus 5x. Okay, this is the simplest form. Let's see another example. So again, this is u. U is 2x cube. So u prime is 6x squared. V is e 5x minus 1. So v prime, using the chain rule, this is u. So e to the power of u times derivative of u equals to 5e 5x minus 1. So y prime is u prime v plus uv prime. U prime is 6x squared times v e 5x minus 1 plus uv prime 2x cubed times 5e 5x minus 1. Again, so we have the common factor 6x cubed square and 2x cubed. So the common factors is 2x squared. Yeah, take the smallest power. And then from e, we have the same e. So we take, okay, I use blue, e 5x minus 1. Okay, now put the remaining. Okay, 6x squared with 2x squared become 3. E 5x minus 1 and 5e 5x minus 1 is become 1. Plus, okay, we have 5. We have 2x cubed and 2x squared. So it's also only x. We have 5 remaining here. And we have e as well. divided by e to the power of 5x minus 1 is 1. So equals, we simplify, it's 2x squared e 5x minus 1, 3 plus 5x. This is the simplest one. Okay, this is the exercise you can do by yourself for your own practice. The key in here is you have to master the chain rule first, because we need the chain rule to solve, to help us in differentiate the product rule. Now, the last rule will be quotient rule. What is quotient rule? Quotient rule is used if we have two or more functions in division. So if product rule is used for the multiplication, quotient will be used for the division. The rule is if y equals to u over v, the y prime is similar with product rule, but now it's minus instead of positive. Yeah, if you remember, product rule is u prime v plus u v prime. In here, it's negative. So u prime v minus u v prime over x v squared. So we can see the example. So this is u, this is v. U is x plus 4, u prime is 1, v is x squared plus 4, v prime is 2x. So the y prime is u prime v minus u v prime over v squared. So u prime is 1, v is x squared plus 4, minus u x plus 4 times v prime is 2x over v squared. So it's x squared plus 4 squared. So simplify, we don't have the same term, the common factor. So we expand it. X squared plus 4 minus 2x squared minus 8x over x squared plus 4 squared. We don't need to expand the denominator, yeah? So it's negative x squared minus 8x plus 4 over x squared plus 4 to the power of 2. That's it. This is already the simplest form. 2. So e minus 2x will be the u, and this will be the v. U is equals to e minus 2x. So u prime is, using the chain rule, this is eu. So the derivative is eu times derivative of u. Minus 2x derived is equals to negative 2. So minus 2 e minus 2x. V is 5x minus 2 to the power of half. V prime, okay, this is u to the power of half. So chain rule, it's half u, and then the power minus 1. So half minus 1 is negative 1 over 2. Times derivative of u. So it's 5. So it's 5 over 2, 5x minus 2 minus half. So we put into the formula, y prime is u prime v minus u v prime over v squared. So u prime is negative 2e minus 2x. V is 5 over 5. X minus 2 to the power of half. Minus u v prime. So u is e minus 2x. V prime is 5 over 2. 5x minus 2 minus half over v squared. So it's 5x minus 2 without the square root because it's being squared. So now, what are the same factors? Okay, let's see. We have e to x, e minus 2x here. So we can put it e minus 2x. And we have 5x minus 2. If you see, this term will be the same as this. But we take the smallest 5x minus 2. We take the smallest power, negative 1 over 2. Okay, and then now we put the remaining term. Okay, from the first one, we have negative 2. And then we have 5x minus 2 to the power of 1, because this is minus half, this is power of half. So if you divide, that means you subtract the power, yeah, half minus negative half equals to 1. So you put 1 here. And then minus e, we have this the same, 5 over 2. And that's it. The 5x minus 2 to the power of negative half is also already in the factor over 5x minus 2. Okay, we simplify. It's e minus 2x, 5x minus 2 minus half. And this one is negative 10x plus 4 minus 5 over 2 over 5x minus 2. So we can simplify. So it's e minus 2x, and then this is negative 10x plus 4 minus 5 over 2 is 3 over 2. And then the power negative half is in the denominator. So I can rewrite as 5x minus 2 to the power of 1 over 2 plus 1. Yeah, I can combine the 5x minus 2. So it becomes e minus 2x minus 10x plus 3 over 2 over 5x minus 2 to the power of 3 over 2. That's it. And the last one, the same. So the u will be 7x plus 4 to the power of 1/3. U prime will be equals to, the u prime will be equals to, so we make it as the u to the power of 1/3. So 1/3, 7x plus 4 minus 2 over 3 times the derivative of the u is 7. So 7 over 3, 7x plus 4 minus 2 over 3. V is 3x minus 5 squared. So v prime is 2, 3x minus 5 times 3. So 6, 3x minus 5. Okay, so now we put into the formula y prime equals to u prime v. 7 over 3, 7x plus 4 minus 2 over 3 times v, 3x minus 5 squared minus u v prime, 7x plus 4, 1/3, v prime, 6, 3x minus 5 over the v squared. So 3x minus 5 squared is 4. Okay, now we simplify. We take the same factor are 7x plus 4 to the power of negative 2 over 3, yeah, the smaller one. And then 3x minus 5 to the power of 1. And then that's it. Now we have the remaining 7 over 3. And we have 3x minus 5 minus 6 of 7x plus 4 to the power of 1 over 3x minus 5 to the power of 4. I can cancel 1 with this. So this equals to 7x plus 4 minus 2 over 3. And then over 3x minus 5 to the power of 3. And the last one, it's 7x minus 42. So it's negative 35x. And then minus with, what is this? 7 times 5, 35 over 3, minus with 24. Yeah. So yeah, 6 times 4, so it's 24. 24 is 72 over 3. So when we minus it, we sum. So it's become 107 over 3. Okay. So that's the final answer. So that's the quotient rule. And this is the exercise. You can try by yourself. Yeah, as a practice. And that's all for the rules of the differentiation. Thank you and bye.